The power supply operates my ham radio, the SB102, and the power supply that I'm going to be modifying is an HP23D, B for Bravo. And let's take a look at it over here. This is the inside of the HP23B. Now, someone has already made some modifications here with this capacitor and this inductor over here, and there's been some work done to it. So all of this is going to be ripped out except for the switches and so on. And let's flip this on its side here and I'll show you the capacitors. These big old capacitors here, these ones here are going to be removed. These paper capacitors, they are 1960s vintage. These four capacitors and all those components here on the back, all of that, those old resistors and those old diodes down there, they're going to be replaced with this circuit board and these components. And that's it. Not this. This. So those are the components that are going to make up the new power supply on this circuit board. And that's what we're going to be doing. We're going to be building that today. Okay, let's get to it then. Now, of course, you have to make sure that you, I bumped the camera. You have to make sure that you orientate these diodes correctly. Now, the diodes have a band on them, and if the silk screening was done correctly, you'll see that there is a band on the silk screen that matches that up. It really is, if it's designed properly, foolproof. However, that being said, you got to understand, occasionally, even the foolproof tends to be, well, not quite so foolproof. There we go. Let us do our first little bit of soldering with the diodes. There we go. First set's done. Now, these little wire clippings, I tend to save a bunch of these up, especially early on in the project, because there are wire jumpers that you have to place occasionally on circuit boards. And these are exactly what you need. Now, some of you may remember these. Wow! Yeah, at one time we had hundreds of these. I don't know how many hundreds I've thrown out. If you can still find them, they are perfect. Little things like that. This was a 35mm film container. Yep, film used to come in that. Back in the days when you had film. Well, we've mounted all of our diodes. Let us flip the board over and mount the next series of components. You always start with the shortest or the lowest level components first, closest to the board, and you build yourself up higher and higher for obvious reasons. Now, I flipped the board too soon because you see these resistors are 1, 2, 3, 4, and 5. Well, that's these resistors here. They don't go on this side of the board. They go on the other side. And they get quite hot. So, according to the instructions for this power supply for the Heathkit, what I need to do is space them up about 1/4 of an inch, which just happens to be the height of one of these little standoff bolts. So we're going to use a standoff bolt as a height measuring tool, and we're going to mount these and solder them in place. We're going to mount them just a little bit higher. This could get a little tricky. I don't think I'm going to be able to do them all at the same time. So there's these two resistors, and then 1, 2, 3. There's 5 resistors in total. Let's take a look at that again. Sure enough, 3 and 2. And there's our 2. And there is our 3. As you can see, they're nicely raised. Now, for further heat dissipation, I can do this. Spread them apart just a little bit. And that'll aid in dissipating the heat. Plus, it makes it look nicer, I think. There we go. This one does not need to be stood off. I can seat this one flush. And I might as well put all the rest of the resistors on while I'm at it. Now, I have a non-bias adjustable HP23 power supply. There's no bias adjustment, which means that I don't use R10, and I've got to place a jumper between here and use this resistor here. Now, it's either R8 or R9, depending on whether you've got a bias adjustable or non-bias adjustable. If I had a bias adjustable power supply, those of you who have the Heathkits know, I would use these two resistors in these two locations, and I would be able to hook up the bias potentiometer that's on the power supply, and it would function. But in this case, this power supply, the B version, did not have an adjustable bias, so I need to install this resistor instead. Those were 1K resistors that would have gone in had there been a bias adjustment. The fact that there is no bias adjustment means that I put in a 27K resistor instead. And the color code, of course, that, for 27K right there. And there we go. So, let's solder those 3 components. Well, 2 components and a jumper. But, if you want to be picky about it. Okay, now we're going to mount the capacitors. All right. We're going to start with the small ones and work our way up. Now, capacitors, these are electrolytic, so they're polarity sensitive. The longer pin is positive, but they also have the negative, or the minus sign placed there, the negative. So that's negative. And notice, positive, nothing there. Therefore, the long pin goes through the positive on this one. We're going to start with the C6, and we're going to seat these nice and flush, as flush down as we can get them. Bend the pin to hold them in place. Then we will do the next one here. Again, making sure that your polarity is correct. You don't want to reverse polarity, because what happens is, if you reverse polarity and you apply power to these capacitors, what will happen is smoke leaks out of them. The toughest part about that is trying to get the smoke back inside. That's really hard. Now, remember, our positives are on that side. C5, notice it's on the opposite, so we got to make sure that we orientate it correctly. C5 is right there, and I will bend these pins just a little bit, just to get them in there. Flip the board, solder them, trim them, and then put the other 4 capacitors in, the big ones, the big capacitors. That, boys and girls, was the last component that needed to be soldered. Last components. Okay, we are done with the board assembly. That, boys and girls, is now an assembled board ready for mounting into the power supply. Plus I have to hook up wires to it and a whole bunch of stuff. But this little board is going to replace all that big honking stuff. Now this little board here, this little board is supposed to fit inside here in this orientation using these standoffs to keep it off the bottom there. So I got to remove those capacitors and what have you, and then this board sits in its place and takes place of all those big capacitors. You know, when this thing was originally built, there's rather some time-consuming work being done here to assemble this. But, whoever put this together originally, well, they spent some time on it, that's for sure. And there you have it. Disassembled, ready for the new board, or almost. There's a few things that need to be done. I need to clean a little bit of paint off of some areas in order to make a proper ground for the new board, but there we go. It's getting there. Okay, I've done some prep work here. I've cleaned a few things up, and I have removed some paint from the bottom of the chassis from over here, here, and here. This was done previously by the other person, whoever did the mods. So these three will allow the circuit board, which will be mounted in here on standoffs, to have a nice electrical connection to the chassis ground. Sorry about jostling the camera again. So, let's get to it. Okay, so I've got that mounted. Let's put this board here and find out whether or not it actually fits. Well, look at that. And there will be enough clearance for the lid. Look at that. Once it gets bolted down, great. Amazing. So it's fitted and will sit there nicely. Okay, let's move on to the next step. Okay, if you're wondering where all these wires are going to and what have you, well, there's numbered jumpers along, or numbered points along the circuit board that are supposed to be met up with specific wires from here. Of course, I have the original instructions which show me the transformer, the color of the wires. This is the low voltage side, that's the high voltage side, that's my input, as well as this plug over here, which goes to the radio, and what color code is over there for these wires. It just so happens the color code matched this exactly. And so the instructions that came with this unit, or this kit, tells you to hook up the high voltage wire, one of the leads to this point, the other lead to that point, and this lead to there, and what have you. What you need to do is you need to read those instructions that comes with it and put the wires in the right spots. Now, I'm going to be doing it over here, and you will see, I'm going to say I'm putting this red wire on this point, and this red-yellow wire on this point, and what have you, and that's the high voltage. These two, of course, high voltage. That's part of the low voltage here. There's also a switching high-low voltage. This is my inductor, and let's just take a look at that. That's not a transformer, that's an inductor. And those are the two leads off that inductor. They get tied to the circuit board. So I'm just going to be telling you where I'm plugging them into, what the numbers are. But if you, when you purchase one of these kits, and you can purchase them from Bob at Kilo 8 Golf November Zulu. That's his call sign. And he runs old-Heathkit-parts at kcom.usa, or .us. And that is his email address. So he also has a website. It's called Old Heathkit Parts. The instructions come on a little CD, and it's HTML based, so it launches a web browser, and it's full of pictures, photographs, drawings. It's really quite comprehensive. Most people, when they do instructions, well, you sort of have to figure out what they're trying to say in some cases. Not with these particular instructions. They're pretty straightforward, but you do have to read them thoroughly at least once or twice before you start putting things together or taking things apart, because it'll make sense. Hopefully this video will aid in that as well as you watch the steps I've been doing. So we'll carry on. We will start soldering some parts onto here, or soldering some wires, I should say, onto here, and I will just tell you what wire is going where. When you do yours, if you do one of your own, you can follow along, and it's like a paint-by-numbers drawing. If you remember what paint-by-numbers is. Kids don't do that anymore, do they? It's too bad. That stuff used to be fun. Alrighty, so let's get at it. Okay, boys and girls, let's talk about what I've been doing here. Yeah, mysteriously, the magic of video here is that we've got it all done. Okay, in a nutshell, what we've got here, first off, let's start from this side here. This red and black wire is connected to pins 8 and pin 9 on the circuit board. That is the inductor. That's your filter inductor. That's soldered to the pins 8 and pin 9. That's a big transformer looking thing down there. This switch here turns between the 275 and the 350 volt tap, and it switches between either one of these two lines coming from the transformer. This is called the low voltage side, and the center common is whatever side is selected. It's tied to pin 3. Now, it's tied to pin 3 because this one doesn't have a bias control. Now, you do not tie anything to pin 3 if you put a jumper between pins 13 and 14 here, but I did not put a jumper because I have this switch, and I don't have a bias control, so I don't have this resistor, and yeah, okay, you'll see that in the instructions. So, this line here from this switch goes to pin 3. From this plug over here, this 11-pin plug, what we have there is a ground on pin 7. It's a brown wire. I couldn't locate any brown wire, so I had to extend it. So I soldered, put some heat shrink on there, and extended it, and it's black. And it gets tied to pin 10. Likewise, the blue wire here from this transformer, which is the ground on the transformer, also gets tied to point 10. There's 2 point 10s inside here. This blue wire here, which is point 4 on this multi-plug, gets tied to input number 7, or point 7. This yellow red wire goes to, which is your high voltage, goes to pin 7. This red wire, which is the other side of the high voltage tap, goes to pin 1. This yellow wire here, which comes from pin number 1 on your multi-plug, it gets tied to pin 5. And last but not least, you need to hook up the 275 volt line of low voltage center tap of this transformer, which happens to be the yellow-brown line on the switch. It needs to be tied to pin 4, right there. So this is really, really a simple, quick build. My next step, of course, is to test. I have to plug this thing in and make sure the magic smoke doesn't leak out. We made one slight change or modification. Of course, we made sure that the hot line was not tied directly to the transformer, and that the neutral line went through the transformer. The hot went through our fuse and switch. So yeah, you just want to make sure of that those things are routed correctly, especially on an old piece of equipment like this that other people have had their fingers in. So yeah, you want to make sure of that. Now, to test this particular device, I have to plug it in and turn the switch on, but that won't turn on because it's looking for a short between pins 9 and 10. So I'm going to have to short out pins 9 and 10 in order to activate this. And then I get my test meter and I will check to see whether I've got a fixed bias volts of 130 volts, 350, 275 depending on the switch, 820 volts. We're dealing with pretty high voltages here. Remember, this is a tubed radio, so we've got some pretty high voltages coming through. And yeah, you got to be very careful that your test meter is at least a class 3 or better. Don't use something cheap and down and dirty. Okay, well, I'm cheating a little bit here. I've already tested it, and it is working. None of the magic smoke leaked out. But we'll just show you just what you should be looking at for here. Notice I have the 2 low voltage settings on here. And I have a low voltage and a high voltage tap. This is all DC. When they say high voltage, they mean high voltage. I've got a little bridge over here. Don't do this at home, boys and girls, unless you know what you're doing. All that does is close these 2 points, which allows power to flow. That simulates the on-off switch at the radio. There we go. Ooh, the light's even flickered. So let's do some testing. First thing we're going to do, this filament common 12 volts and common here is AC voltage. We're going to check that. We're going to check to see what we get out of that. And we get 14.6 volts AC. That's pretty good. That's right on the spec where it should be. Now we'll go to our DC voltage. The DC voltage, we're going to be testing from this ground point here, and I've got it switched to the 250 volt. Well, it says 250, it's actually 275. So put the probe inside there. First thing I'm going to do is 130 volts DC. We'll check that tap there. There we go, 138.5 volts DC. Then we're going to check the low voltage tap on there. And look at that, we have got 289 volts. And our high voltage side, we have 828 volts, which is right on spec. It says 820 is where it should be. Now let's just change this to the 300 volt tap, and let's see what happens to our low voltage side. And low voltage now reads 370. It should be 375 actually, but that's okay. We're good. We're well within specifications. So everything worked out great. This power supply is rejuvenated, and I just got to put the bottom cover on there. One last look at everything, make sure that there's no wiring that needs to be cleaned up. Nothing bare, nothing loose, nothing that could cause a problem. And then I put the covers on and mount it back in its box and fire up the old radio and see how she works. Thank you for watching. Once again, I purchased this rebuild kit from Old Heathkit Parts. He's got a website. Just look up Old Heathkit Parts. And his name is Bob, Kilo 8 Golf November Zulu is his call sign. And his email address here, of course, old-heathkit-parts@kcom, that's Kilo Charlie Oscar Mike, .us. And that's it. My name is Peter, BE4 Tango Tango Hotel, and I hope you enjoyed this little presentation on how to convert a Heathkit HP23 Bravo, a vintage late 1960s, to an HP23 Delta, vintage 2015.